All right, good evening, folks. I've got a mystery guest with me, one guest, and we're going to tackle the next lesson. So last lesson we did 4.2 where we did like denominators, and it was pretty straightforward. The denominator gave us the size of the pieces, and we basically just added, subtracted. The only tricky thing is sometimes we had to simplify at the end. But we talked about how the next lesson, where the denominators, the bottoms of the fractions are different, how that would complicate things. So we're gonna basically deal with two methods today. But first, let my guest say hi.
Hi, everybody.
Oh boy. Okay, guest, please talk in a normal voice. That was silly. All right, so let's go ahead and let's get started. And let's. Wow, that's weird. Let's take an example. So let's start with 2/3 plus 1/4. Okay. All right. So the problem with this, and the reason we can't just attack it like we did last night, is the bottoms 3 and 4 are different. So imagine taking candy bars and breaking them up into, in the first example, breaking them up into 3 pieces. Okay, your pieces are going to be pretty decent size, right? 1/3 of the candy bar. But in the second example, you took a different candy bar, and this one you broke up into 4ths. So you could say, okay, how many pieces do I have here? And the answer is we do still have 3 pieces. The first fraction represents 2, and the second fraction represents 1. The problem is that because the pieces are different size, we can't combine them. We can't say I've got 3/3, because I don't, and I can't say I have 3/4 either, okay? So we clearly have a problem here. And the only way to really solve that problem is to take the 2 candy bars that we've broken into either 3rds or 4ths and break them up into smaller pieces so that all the pieces are going to be the same size. We'll figure out how much we've actually got, and then we'll be able to put it together and find out just how much candy we have. All right, so that's basically the idea here. So what we have to do in order to do that is we're going to have to get these denominators to be the same. All right, now there's 2 ways to do that. One way, which is very algorithmic, is called the rule of 4. And it's called the rule of 4 because it has 4 steps. Okay, so I'm going to walk you through that. So imagine we have 2/3 plus 1/4. Okay, here's what you do. For the rule of 4, what you do is you just multiply the 2 bottoms together. So we're going to start by multiplying 3 times 4, and that'll give us 12.
Yep.
Okay, now steps 2 and 3 are a little different. What we're going to do for those is we're going to do a crisscross. Okay, so again, just like when we were comparing fractions, we're going to start at the bottom. We're going to go 3 times 1 is going to give me 3, and 4 times 2 is going to give me 8. Okay, so that's steps 2 and 3. Then I add those 2 things together, and I'm adding them precisely because right here I had a plus. So add 8 plus 3, and that gives me 11/12. Okay, yep. And let me change colors here. That is my answer by the rule of 4, 11/12.
I like the rule of 4.
Okay, now for simple fractions, especially fractions where the smallest common denominator you could possibly have found is going to be the product. And that's the case here because you have 3 and 4, and 3 and 4 are kind of that worst case scenario. They don't have any common factors.
Yeah.
So the only number, the least common multiple, that we could break those things into, that they'll both go into, is the product. Okay, and so all right. So I'm already talking about terminology from the other methods. So let's go ahead and do it. So there's the rule of 4. So step 1 is to multiply the bottoms. Step 2 is to do the crisscross. Okay, that's actually steps 2 and 3. And then step 4 is you put together. Now sometimes you have to reduce this final answer. So some people say that step 2 is to do the crisscross. Step 3 is to add. Step 4 is to reduce. It doesn't matter. Okay, it's the same steps. All right. So let's go to the other way to do it. The other way is to find the LCD, the lowest common denominator, and that is nothing more than the LCM of the 2 denominators. Yep. Okay, it means the same thing. So that's why we just did LCMs last chapter, and now we're going to do LCD this chapter. All right, so in this case, again, we've already talked about this. The only number that both 3 and 4 go into, if you try to do a division ladder, nothing goes into them. Mm-hmm. So you end up having to multiply anyway. So the common denominator is 12. And very similarly, what we ask ourselves, okay, if I had to change 3 into 12, I had to take each of those thirds and break it in 4 pieces. I multiplied by 4. Well, I have to do the same thing to the top. So 2 times 4 gives me 8/12. So I've rewritten 2/3 as an equivalent fraction. We've talked about that this chapter. It's 8/12 is the same fractional amount as 2/3. It's just broken into smaller pieces. Okay, and if you think about that, you could actually draw a picture of that. If I had 2/3 of a candy bar here, let's go ahead and draw one out. I'll draw it into 2/3, and suppose I have these two pieces, right? That's 2/3.
Yep.
Well, if I took that same candy bar and I broke it instead, draw a line down the middle and draw another line and break those up. Now I've got 12. Well, it's not quite even.
Yeah.
Let me fix that. Let's try to make them even. All right, now we've got 12 equal pieces, and you'll notice that the exact same amount of candy is now what? 8 out of 12.
Yep.
Okay, so it's the same fraction. We do the same thing with the other one. Let's go ahead and change colors here. Okay, so to get 4 to change into 12, I have to multiply by 3.
That means you have to do
So
the same thing to 1.
do the same thing to 1, multiply it by 3, and I get 3/12. And you'll notice that this is very similar to the numbers we got with the rule of 12. 8 plus 3, 8/12 plus 3/12 is 11/12. And again, we try to reduce it, but nothing reduces, so we get the same exact answer.
Yep.
Now this is doing, now you notice there's a lot of similarity between the math, okay? All right, well, we're going to pause the video right now because we just ran out of class time, and so Kevin has got to get to class, but, I gave it away.
Yeah, you did.
You'll see his picture at the very end.
Oh, well.
But thanks very much for your help,
No
my
problem.
friend, and
Bye.
I'll be right back, and we'll finish up this recording. Okay. Let's get back to this video, and let's wrap this up. Okay, so in this case, we go ahead and we add the 8/12 and the 3/12, and now everything is the same size. They're 12ths, and so we get 8 plus 3 is 11, and we get 11/12. And again, you'll notice this problem, the rule of 4, and doing it with lowest common denominators actually worked out to be the same. And the reason for that is because in this case, the lowest common denominator was the product of the two denominators, 3 times 4. All right, so let's look at the differences of the two methods. So let's do a slightly different problem. This time, let's do 3/4 plus 1/6. Okay, first let's do it by the rule of 4. Okay, so by the rule of 4, what I'm going to start by doing is multiply the two denominators. 4 times 6 is 24. Okay, next I'm going to do the crisscross. Oop, hold on, let me back up for a second here. All right. Okay. All right. So let's do the crisscross next. We get 4 times 1, and we get 6 times 3. And if I do that, I'm going to get 18 plus 4, which is equal to 22. Okay? So, and again, so far, what have we done? We've multiplied the two bottoms. We've done the crisscross. 6 times 3 is 18. And 4 times 1 is 4. We add those together, we get 22 over 24. Now, the only catch here is this is not reduced. If you left it like that on a test, you get an R minus 1, which means you didn't reduce the answer. So what we have to do to finish this is we have to take out the common factor from the top and the bottom, which in this case, they're both even. So take out a 2, and I'm going to get 11 over 12. Okay, and that's doing it by the rule of 4. All right, now let's go forward. Now let's try it by doing it the LCD. So we're going to start by finding the lowest common multiple, or the least common multiple, the lowest common denominator of 4 and 6. All right, and so you could probably do this one in your head. The first number that both 4 and 6 are going to go into, you go ahead and do a division ladder. You can take a 2 out, you get 2 and 3. You multiply across, you're going to get 12. Okay, that's the least common multiple. So that's going to be the denominator for both of these. Okay, now what we do is a little different. 4 goes into 12 3 times, so I had to multiply that by 3 to get the common denominator. So the top, 3 times 3, gives me 9. Okay, and the 6 goes into 12 twice, so multiply the top by 2 and you get 2. And now when I add up 9/12 plus 2/12, you get 11/12. So really the only difference with the two methods is by doing it with lowest common denominator, at the end I already have a reduced answer. And usually it's reduced all the way to simplest terms. Sometimes you still have to reduce a little bit more, but usually it'll already be the final answer. Whereas if you do rule of 4, anytime the product is bigger than the least common multiple, you'll end up with an answer that has to be reduced at the end. Okay, both of these methods work. Up until this year, I've always taught exclusively the lowest common denominator or least common multiple method. But I do think that the rule of 4 has value. What I would strongly recommend is that you pick one of these methods and that you really, really understand what you're doing. Okay, either method that you use, you really have to show your work. So with the rule of 4, you notice the arrows. You notice that I'm showing my individual pieces. So as I was doing the calculations, I showed the product. I showed the products of the crisscrosses. I added them together, and I showed the work when I reduced. Okay, when I do the least common denominator, because the problem was kind of up and to the left, usually the arrows are not going to be all over the place like this, but notice there's an arrow for each of them, and really each of the arrows should be labeled. So the first fraction, I multiply the top and bottom by 3. The second fraction, I multiply the top and bottom by 2. I got my common denominators, and now was able to add the fractions together. Okay, let's do one more example. Let's do this one again. We'll do it both ways. And again, I think you'll see the benefit of the least common denominator method, but both methods work. So we'll start by doing it with the rule of 4. So we'll start with 12 times 10 is equal to 120. We'll do the crisscrosses, okay? And it is very important in this one that we do the crisscrosses in order. So we'll do the first one starting with the 10. 10 times 7 will give me 70. Because there's a minus on this one, and 12 times 1 gives me 12, and 70 minus 12, you can go ahead and do a side problem if you need to, otherwise you figure out that that's 58. 58 over 120 is my first answer. Now let's reduce that. Let's take out a 2. I get 29 over 60. I look closely to see if anything else comes out. It looks like that's the final answer. Okay? If I do it with the least common multiple, or the lowest common denominator method, I'm going to look at 12 and 10, and I'm going to find the least common multiple of those. In both of these, I can take out a 2. I get 2, and I get 6 and 5. This is going to be the GCF. Multiply across the bottom, and 2 times 6, actually 2 times 5, let's do that first. 2 times 5 is 10. 10 times 6 is 60. So in this case, I'm going to use the common denominator of 60 for both fractions. Okay, 12 goes into 65 times, so multiply the top by 5, and I'm going to get 35. Okay, I'm running out of room, so I'm not actually writing down the times 5s, but I'm talking them through. 10 goes into 60 6 times, so 1 times 6 is 6. And again, this was a subtraction problem here. Make it nice and dark. So it's going to be a subtraction here. 35 minus 6 is 29 over 60. And again, I get the same answer, except now I don't have to reduce with the white one. With the red one, I had to reduce. But I do get the same answer. So, there we go. Okay? So that's what we're going to do with fractions with unlike denominators. We're going to get common denominators, either by doing the rule of 4 or by finding the least common denominator, which is exactly the same thing as finding the least common multiple of the two bottom numbers. Okay? All right, so hopefully that all ties in. Don't worry if you need to practice this, because that's what class is for. We'll have classwork tomorrow in class where we will go over this and we'll practice a bunch of these problems, and we'll probably practice both methods in class. Then I want you to kind of pick the method that you feel more comfortable with and do the problems that way. All right, we'll see you tomorrow. Thanks for watching. Bye.